Hi, I'm Danielle. I'm a chemistry major from the Pennsylvania State University, and I'm going to talk about the environmental impacts of coal mining, specifically acid mine drainage. Coal is used to generate approximately half of the electricity produced in the United States. Coal is a very dirty energy source, from the mining to the cleaning, burning, and the disposal of waste products. Coal mining has several negative impacts on the environment. Some examples include soil erosion, scarring of land, destruction of habitat and wildlife, and also contamination of soil, groundwater, and surface water. Water supplies are commonly contaminated by acid mine drainage, which is a result from coal mining, and it is the outflow of acidic water from coal mine sites. When coal is mined, it exposes sulfide-bearing minerals like pyrite. Acid mine drainage forms when pyrite reacts with water and air to produce sulfuric acid and dissolved iron. This is then carried off by rainwater or surface drainage, further dissolving heavy metals like copper, aluminum, zinc, arsenic, mercury, and manganese. It is then discharged into streams, rivers, and lakes, and it can also seep into groundwater. This is a problem because it contaminates water supplies. Acidic water with a high concentration of metal ions increases the toxicity of the water. This causes physical stress to plants and animals, impacting biodiversity and also food sources for humans. It can even result in biological dead zones. These are two examples of acid mine drainage. In both photos, you can see this bright orange color. That is from iron hydroxide precipitating. In the first photo, this white strip is from aluminum precipitating, and then the second photo, you can notice that most of the vegetation is dead. The most cost-effective and low-risk strategy to prevent acid mine drainage formation is through prediction and mine planning. It is possible to create mine designs in a way that minimizes the excavation of sulfide materials. However, in areas where sulfide mineral excavation is unavoidable, other strategies have been developed. Some of these strategies include flooding and sealing of underground mines. This is done where it is possible to completely isolate the mine by sealing off all entrances, therefore preventing water from entering or exiting. Also, covering waste rock with clay, plastic, or soil can be done to reduce the amount of oxygen available to react with pyrite, and it also prevents precipitation from forming acid mine drainage and transporting it. Also, wastes can be blended with alkaline materials to neutralize the acid mine drainage. Some may say that the solution is to stop coal mining and to invest in alternative energy sources. However, the acid mine drainage that is occurring today is from coal mines that were abandoned a number of years ago. So the acid mine drainage cannot be prevented there, but it must be treated. So acid mine drainage can be treated either actively or passively. Active treatment requires ongoing inputs of artificial energy or biochemical reagents. This can be expensive, it can produce sludge with a high metal content, and it also consumes large amount of fossil fuels from chemical transportation. One way to offset the cost for this water treatment is to concentrate the sludge into a marketable resource. Passive treatment is a self-operating system that treats the water using enhanced natural processes without constant human intervention. There has been a particular interest in the passive treatments because of the low operation and maintenance costs, and full systems have been constructed with constructed wetlands and bioreactors. However, new innovations are being looked into, like microbial reactors, microbial fuel cells, and filtration and ion exchange. And this is my references, and thank you for listening.